Today on How It's Made Dream Cars, Lamborghini's fastest raging bull, the spectacular Aventador. Lamborghini was founded in 1963 by Ferruccio Lamborghini in northern Italy. Lamborghini was already a wealthy man manufacturing farming tractors. Sports cars were just a passion for him. Past and new dream cars live in the Lamborghini Museum. The first car to own a Lamborghini nameplate was the 350 GT, introduced in 1964 with just over 100 models made. With a 3.5-liter 12-cylinder and a 4-liter V12 engine, Lamborghini redefined the notion of the supercar with the Miura, which they produced between 1966 and 1969. In 1969, the 370-horsepower Miura S was launched on the market. The ever-popular Countach from the mid-70s produced Lamborghini's legend, a signature design with a wedge-shaped body and scissor doors left enthusiasts and onlookers speechless. Lamborghini's newest legend is the Aventador, embellished with raw power, lightweight engineering, and remarkable handling. This car achieves 0 to 60 miles per hour in 2.9 seconds and a top speed of 217 miles per hour. With a lightweight monocoque structure made from carbon fiber, an aluminum chassis, and a 6.5-liter 12-cylinder 700-horsepower engine, it's a high-revving package of extreme performance. The cell of this sports car is a monocoque frame and is made from carbon fiber parts. It also includes epoxy foam sections, adding the space needed to create shapes without introducing unnecessary layers of carbon fiber. It makes the vehicle extremely robust and light. In a climate-controlled dust-free room, workers pull a large sheet of resin-impregnated carbon fiber onto a vacuum-based cutting table. Next, a protective film is applied over top and is vacuum sealed through the pores of the carbon fiber sheet. The computer-controlled cutting machine determines the location of the cutting strokes to maximize the material's usage. The cutting table is a flatbed cutting machine that uses an air suction system under the table's surface to completely flatten the carbon fiber sheet. When cutting, the ultrasonic knife uses a pressure wheel to hold down the fabric to create accurate patterns with clean edges. After removing the plastic film, the workers carefully pull and inspect the newly shaped carbon fiber mats, trimming away any unnecessary areas with fabric shears. The pre-cut mats are then grouped together pertaining to their specific position within the construction of the support structure. Next, the pre-cut carbon fiber mats are fitted onto the hollowed monocoque molding patterns. Each new mat has a self-adhesive backing and must be fitted precisely into the mold pattern. The material's patterns have to match and crisscross in order to construct the appropriate thickness and strength. Only a small amount of material can be used to ensure the vehicle remains light in weight. After removing the protective film from the fiber mat, the workers manually affix the material into position, using a 4-inch plastic squeegee to sweep away any air pockets. The edges of the mats are overlapped at the intersections of the molding, eventually allowing the carbon fiber mats to become one complete element of the car at a later stage. Since the monocoque is composed of a range of small to very large sections, the pre-cut mats are sometimes applied with ease or require extensive attention and sweeping. Workers place a protective plastic cover over the mold, followed by a white cloth. A thick plastic vacuum bag is applied over the cloth covering. Using couplings connected to vacuum hoses, this operation forces the layers of carbon fiber to shape against the mold by removing air and applying gravitational pressure. The mold cures in an autoclave at a temperature of 275 degrees Fahrenheit. This forces the carbon fiber mats to release the resin into all areas of the fabric against the molding. Workers remove the vacuum bag and the protective white cloth to reveal the solidified carbon fiber monocoque. The molding elements are then disassembled for the easy removal of the monocoque structure. The extracted roof section of the monocoque is manually transferred onto a work cart, where any excess resin is removed manually, along with an automated CNC machine. The monocoque also needs lightweight epoxy foam. A technician removes a protective wrapping sheet from a pre-cut mat of carbon fiber and heats the self-adhesive backing with a blow dryer. She places the fiber mat evenly onto the foam structure and sweeps the area for wrinkles. Then the green protective wrapping sheet is removed, showing the carbon fiber texture. She evenly applies pressure to the mat against the foam structure and sweeps for air bubbles with the plastic squeegee. The self-adhesive backing is reheated with the blow dryer and then fitted. The biggest advantage of the epoxy foam is that the lightweight material can be shaped and fitted in almost any way. This epoxy foam component will be placed in a strategic position of the carbon fiber monocoque to increase its stiffness and rigidity. The car's foam elements will exist as spacers between the composite layers while also dampening any noise and vibrations. In this stage of the assembly process, workers use a transfer dolly and pneumatic lifting device to manually assemble the tub and roof elements of the monocoque for the Lamborghini Aventador. The Lamborghini Aventador's lightweight carbon fiber monocoque and aluminum chassis are labor-intensive to produce, so 146 carbon fiber specialists create only 4 monocoques every 24 hours. In the late 1980s, the automaker experimented with a chassis and body made of lightweight composite materials, which produced valuable design information for future vehicles. The look of any car is vital, but this car's styling is revolutionary and recognizable. The designers constantly sketched new renderings that were extreme. Aeronautics also plays a large role in the car's design, integrating beauty and functionality, like the styling of jets and airplanes. Carefully, a technician slides the rear chassis to be connected with its counterpart. Then he manually bolts the parts together. More chassis brackets for the roof are installed and fastened into position. Once the front and rear chassis components are affixed, an overhead air hoist maneuvers the frame to another workstation for the installation of the car's body panels. At the next workstation, workers navigate the rear body shell panels using an automated transfer unit, which precisely applies the panels to the frame. When the rear panel pieces are applied, the automated transfer unit moves away for the workers to continue the installation. Next, the workers inspect the placement of the rear panels to ensure that they are properly aligned with the frontal panels. Afterward, a technician slides another holding brace into position so bolts can be applied. Looking more like a superior sports car, essential body parts are fastened, like the aluminum front bonnet, doors, front and rear fenders, as well as the unique carbon fiber engine hood. Mounted onto a transfer hoist, the frame and body is sent to the off-site paint shop for the body's coloration. In the paint shop, the first stage is the elimination of defects and the application of primer paint. Then, in the second phase, a technician manually sands the primer-coated shell in preparation for the base coat. 13 paint colors are optional for the flagship ride, and painting this car is an extensive process. All 27 parts of the car's body are manually spray painted, with a total of over 2 gallons of paint. Over 200 hours are spent painting each body, more hours spent than any other car in the manufacturer's history. Once the paint is completely dry, a technician repeatedly buffs the surface, removing any imperfections, creating a smooth and glossy finish to the body. Almost 3 days are spent on the polishing process for the perfect glow. Before the body leaves the paint shop, it sits in the ZP5 Quality Control Checkpoint, a specialized light tunnel where it undergoes heavy scrutiny for 2 hours by the manufacturer's certified auditor. He verifies the quality of the work and marks any imperfection with the technical pencil. If there are any flaws found, the body is sent back for either repolishing or repainting. The coated body of a Lamborghini Aventador is not allowed to leave the shop without the auditor's sticker of approval. Lamborghini has long incorporated V12 engines in their cars, but the engine doesn't solely define the Aventador's drive. The independent shifting rods of the lightweight transmission has shift times quicker than the blink of an eye. The cooling system of the car's engine requires a thermostat, which sits between the engine and the radiator. In the case of this car, it has 2 thermostats. The thermostat is positioned, followed by the cover and screws, and then fastened with a servo driver. Another technician puts round elastomer O-rings into a central groove of each cylinder liner. The rings close off the passageway between the cylinder and its block, preventing any unwanted loss of vital fluid. Next, the technician gently places each cylinder liner into the cylinder block. He hammers them into position using a rubber mallet and a plastic guide. Manually rotating the cylinder block once again, he sets it into another position in order to install the heavy crankshaft with the help of an air hoist. It's placed directly into the crankshaft main bearing cap casing. The responsibility of the crankshaft is to transmit the car's torque. The transmission of torque is done by gears, bevel gears, belts, chains, as well as through the pistons and connecting rods. Once all the elements are properly installed, the housing cover known as the crankcase is attached. Once the crankcase is applied, the technician manually cranks the crankshaft to ensure the machinery operates perfectly. Rotating the cylinder block into another position, he installs the pistons and connecting rods into each cylinder sleeve. He gently taps them into position with the aid of a specialized installation guide. On the receiving end, the piston rods align with their crankshaft counterparts. When every piston is in position, they are fastened to the crankshaft using a servo driver with the appropriate screws and bolts. Again, the technician manually rotates the crankshaft to observe a proper motion of the pistons. Using a special multi-head driver, a technician fastens the bolts that secure the cylinder head covers to complete the engine's part. Structural repair to the car's monocoque requires the skills of the flying doctors, workers who travel for the specialized service. Knocking on the frame with a large coin, the technician can detect the acoustic differences in the structure's solidity and determine the areas that require attention. He marks the damaged area using a white marker and indicates instructions for the necessary cut lines and placement for patches to be affixed. Severe damage to the monocoque is repaired with patches of layers of carbon fiber. After precisely cutting out a damaged area, the technician inserts a backing piece that is slightly larger than the hole and has paste adhesive around the edges. Using aluminum foil tape, He maneuvers the backing plate into position. Temporary holding rivets are installed into the two holes that were drilled into the monocoque and away from the edges of the backing piece. Shortly afterward, when the backing plate is firm and functional, the rivets are removed and the patching begins. A larger oval dual-sided adhesive layer is placed over the cut area and in front of the backing plate. Using a plastic squeegee, the layer is smoothed and any air bubbles or creases are swept away. Next, a smaller oval carbon fiber layer is mounted over the larger layer and in front of the backing plate. Lastly, an even larger layer is applied to the entire repair space as the final covering. Again, the material is squeegeed before the patch section is vacuum sealed, and a heater blanket cures the resin in the many layers. And that is how the Flying Doctors fix damage to the monocoque of the Lamborghini Aventador. The Lamborghini Aventador is not only extremely fast, but it is extremely safe because the monocoque has high torsional rigidity. It guarantees that the Aventador has a superb feeling of solidity. The assembly shop consists of 11 workstations. At one station, in an automated harness, the car is rotated on a 90-degree angle. A technician installs thermal acoustic insulation blankets, complete with peel-off self-adhesive backing. Next, he positions and mounts the coolant hose onto chassis holding clips located on the undercarriage. Once the hose is set, using a specialized fastening gun, the pipe is secured into position, and then the vehicle is rotated back to its formal stance. Next, the transfer case, which is a part of a four-wheel drive system, is connected to the transmission as well as the front and rear axles. The transfer case receives power from the transmission and sends it to both axles, rotating the wheels. It is mounted using a unique lifting device and then manually fastened with an air ratchet wrench and corresponding bolts. For authenticity and identity, each frame is engraved with the model type and year of production. Etching the owner's name is even an option. With the assistance of a lifting device, workers install the dashboard, ensuring that the console part fits securely. The dashboard color is always individualized, with options like single color or two-tone leather and stitching. The rear of this supercar is the most complex part of this vehicle. In another section of the assembly shop, workers maneuver the V12 engine, the gearbox, and other engine components over and into the rear midsection of the body frame. They also attach the specified cabling and piping along with the necessary screws and bolts. Because of very high speeds, the most important characteristics of the pushrod suspension are the shock absorbers, uniquely connected inboard to the body and transversely positioned. This makes handling extremely responsive and precise. A technician installs the integrated rear wing, which is vital to the vehicle's performance. It only extends when needed, pushing the rear of the car closer to the road and creating downforce, which affords the tires better gripping. He also ensures the placement is accurate with a measuring device. The motion of the rear wing is tested to verify its 3 selective positions. Next, the workers position and install the rear bumper. A technician situates the leather bucket seats into the cockpit. The pneumatic arm makes it easier to insert any electrical wiring in and around the seating. Next, workers install the famed scissor doors using a specialized lifting device. The first car to use this door design was constructed in 1968. The suspension system uses a pushrod system. Together with aluminum double wishbone control arms and carbon fiber ceramic brake system, a bell crank actuates the internal, vertically integrated spring and damper unit. This allows the wheels to be glued to the road when taking tight turns, especially when the car reaches speeds of up to 186 miles per hour. The optional black alloy rims and performance tires exude sportiness and ultimate control. Rolling out of the assembly shop, the car is ready for driving tests. Like a futuristic spacecraft, both scissor doors can open upward by remote control with a keyless entry device. This is a new feature to the car. Sitting in the lap of extreme luxury never looked better. The center controls look greatly inspired by a fighter jet, even down to a red switch cover that starts the 12 cylinders. Named after one of the most courageous bulls in Spanish bullfighting history, the Aventador is an automotive beast with razor-sharp design, exclusive technology, and lightweight construction, powered by the traditional Lamborghini heart of a V12 engine, combined with an innovative transmission. This car outputs maximum revs and spine-tingling echo.